Hello and welcome to today's 26th webinar in the On the Move webinar series, Mobile Robotics in the Warehouse, brought to you by Honeywell Intelligrated. I'm Tracy Niehaus, Director of Marketing for Honeywell Intelligrated, and I'm your moderator today. We have just a few announcements before we begin. Please note that this presentation's audio is provided by phone number or through your computer sound system, so be sure to turn up your computer's volume. You may ask an online question at any time throughout today's presentation in the Q&A feature along the bottom of your screen. Simply type your question into the text area and hit send. Questions will be addressed at the conclusion of the presentation, with the exception of technical questions that can be asked and will be answered real time. Please note that we recommend that you be hardwired when attending this webinar. A Wi-Fi connection may result in lag time in slides updating and graphics loading. Today's webinar includes polling questions. Please feel free to answer these questions as they appear on your screen, and be sure to click submit, and we will include your response when we are sharing the results real time during the live event. If you'd like to revisit key sections of today's webinar, it will be available on demand at intelligrated.com/on-the-move approximately 48 hours after this live event. You'll also receive an email in a couple of days with a link to the recorded event. Now on to the presentation, Mobile Robotics in the Warehouse. Discussing today's topic will be Matt Wicks, Vice President of Product Development for Honeywell Intelligrated, and Joe Lau, Head of Channels for Fetch Robotics, Inc. Matt has more than 23 years of experience in the material handling industry, with expertise in the areas of controls and software integration for high-volume manufacturing and distribution systems. He also has extensive experience in the field of advanced robotic solution development, including robotic solution integration. He holds a bachelor's degree in electrical engineering from the University of Missouri-Rolla and currently serves as second vice chair on the Robotics Industry Association Board of Directors. Matt is also a registered professional engineer in the state of Missouri. Joe Lau is the head of channels at Fetch Robotics, where he oversees the partnerships for the company. Prior to joining Fetch Robotics, Joe was an associate vice president of enterprise products at Synnex Corporation, one of the largest IT distributor manufacturers in the world. During his 17 years at Synnex, Joe served in both product and business development roles with P&L responsibilities for commodity and enterprise businesses. And with those introductions, the webinar will now begin.
Thank you, Tracy. Appreciate it. So my name is Matt Wicks, as Tracy has introduced, and we've got Joe Lau as well from Fetch Robotics. So we want to dive in here and talk about mobile robotics. But before we get into the details of mobile robotics, we want to talk a little bit about market factors and what's happening in this space in robotics, and then we'll dive into some of the details and use cases around mobile robotics. So if your household is like my household, you're seeing an uptick in the amount of online shopping that you're doing. We're seeing up to 10% of the total retail sales right now are done online. That's a tremendous amount of volume. We're also seeing a growth of 20% between 2018 and 2020 in this volume. The amount of people, or the people that are purchasing things online, is not necessarily just millennials or people that are not familiar with or familiar with online, getting online. It's all age groups, from the young folks all the way up to the grandparents. Everybody is shopping online. So one of the challenges this is presenting in the supply chain is to be able to fulfill all those retail orders. Today, a substantial amount of operations in the warehouse are still done manually. Up to 80% of the operations, it's the norm of manual operations. And so we're seeing this acceleration in e-commerce and distribution, up to 25%. And with this, the industry is outpacing this growth of the availability of labor by a 6-to-1 margin. So it's creating a lot of challenges here in the industry. In addition, so I mentioned the workforce is getting older. 30% of the workforce is 55 or older. The cost to rehire people are 25 to 100%, 125, 150% of the employee's annual salary. It's very expensive to rehire labor. In 2017, 600,000 people or jobs were gone unfulfilled in the warehousing space. That leads to loss in productivity, loss of orders, delays in shipments. It's a challenge and an issue in the retail environment. So in the warehouse also, a lot of the jobs are very repetitive. They're very injury prone. 5 injuries per 100 full-time warehouse workers. It's 50% higher than the overall average in the industry. As I mentioned before too, the growth in the industry is really outpacing the ability for the labor pool to be able to supply the individuals here to be able to do this work. So let's get into our first polling question. So when you're considering the use of robotics in the warehouse, what are your focuses? Are you focusing on the labor savings and labor availability, reducing the amount of injury rates, productivity gains, quality improvement, or some other factors? So most likely you're focused on a lot of these things, but looking at, well, what's the top driver here for this? So you should be seeing a pop-up on your screen that allows you to respond to this poll. So while you're filling that out, I'm going to talk about, so why robots in the warehouse and why now? So we've seen robots out there for many years, 25 plus years. Robots have been doing work in manufacturing space. It's a very structured environment. Things like in the automotive industry, there are robots doing work all the time, but you don't necessarily see or haven't seen that primarily in logistics. Well, one of the reasons is because robots are very good at doing things very repetitively over and over again, but have historically been not particularly great at doing things that are very unstructured and more chaotic. And really, that's what the warehouse is. It's a very chaotic environment, lots of different shapes and sizes and configurations of the products, and lots of different configurations of where things are located in the facilities as well. So we're seeing a trend that robots are enabling, or the technology is actually enabling robots to thrive in this more unstructured environment, which is the warehouse and fulfillment operation. They're able to do this through things like vision systems, sensor technology, grasping technology. Mobility is a key factor here, software and machine learning. So all of these things are allowing robotic solutions to be able to function in the logistics environment like they've never been able to do before. So can we see the results from the polling question? Okay, so we're evenly split here between labor savings, availability, and productivity gain. So they're in head-to-head, maybe just slightly favoring the labor savings and the availability. So it sounds like a lot of our audience has the same kind of challenges that I articulated just a little while ago. Is they're having struggles just finding the labor to do the work that they need to get done. Okay. All right. So let's bring in mobile robotics, but let's do a little level setting here. So the term mobile robotics is thrown out there quite a bit. So what do we really mean by mobile robotic technology? So we hear the terms mobile robot, AGV, AMR, LGV, a lot of different terms that are used. And they're reused somewhat interchangeably. But at the end of the day, these mobile machines consist of essentially a vehicle and a payload that the vehicle is moving around and some form of guidance system. So a lot of the technology that we'll talk about today is revolving around what we're calling an AMR. An AMR is essentially one of the more sophisticated type of mobile robots. It uses sensors and onboard navigation to be able to allow the robot to autonomously navigate around obstacles in its environment, be able to interact with that environment. So as things change and are unpredicted, that it can react to those environments. So that's primarily around what we're calling the AMRs. AGVs and LGVs are essentially the same type of class. AGVs are generally considered more of a heavy-duty type of mobile unit. Typically, it goes in with using infrastructure, adding lasers or adding wires in the floor. That's historically where an AGV has been referenced. So why mobile robots? So some of the advantages behind mobile robots are they're very cost effective. It's very economical to get started here. Typical deployment costs are lower than what traditional industrial robotics in many of the applications are. In general, little or no infrastructure is required to get some uses out of these robots. Integration, generally speaking, is you can exist around existing workflows, so you can integrate them into current operations fairly seamlessly. They're scalable, so if you start out maybe with a small pilot program and now you see your business grows, you can add more robots and to be able to seamlessly integrate with your operation. They're adaptable too, as I mentioned before. They've got sensing capabilities and they can sense the environment around it and make the appropriate decisions. And so you don't necessarily have to have a lot of fixed infrastructure, or your infrastructure can change and the robotic solutions can adapt. The last one's improved capability. So this gets more into the mobile manipulation piece. So a lot of fixed articulated arm robots have challenges with regards to reach envelope and may limit their capabilities and capacity. And so adding mobility to a mobile manipulation solution adds additional functionality that we wouldn't have otherwise in a static solution. So I'll talk actually about those examples here in a little bit. So let's talk a little bit about Fetch and Honeywell. So we have a strategic relationship with Fetch, and the organizations together bring and combine the robotic integration expertise of Honeywell, as well as our broad product offering with some of the unique AMR technology that Fetch has to offer. We look at these AMRs can be leveraged as anywhere from a very simple integration all the way up to a part of a larger complex integrated system. And we do that all that integration of all of the equipment. So whether that be the upper level software, the conveyance and sortation, or the integration of the mobile robotic solution. So we see that Fetch brings a unique solution to the table. So with that said, I want to ask Joe to talk a little bit about Fetch Robotics and some of the use cases for the mobile robotic solutions.
Sure, thanks, Matt. Just to give you guys a little bit of information around Fetch Robotics, we were founded in 2014 and we're based in the Silicon Valley. Our organization and our leadership have very deep roots in history around the development of autonomous mobile robots, and we're also quite involved in the continuing evolution of autonomous mobile robots, safety standards and such within the robotics community. Slide. What I wanted to do here was just provide a sense of the breadth of mobile robotic solutions and options that are available in the market today, not just for moving material. I think that tends to be a very common use case that people immediately recognize, but also around tracking assets or doing data collection. Based off the picture here, you can see also the variety of ways that this AMR technology interfaces with either warehouse or manufacturing associates and other pieces of existing automation as well. The other thing to note here is that we've also moved beyond just thinking of AMRs as disparate units, but really around delivering AMRs and AMR technology as a full solution via a platform that can truly deliver that enterprise management, visibility, and support functions as well. Next slide. And so here you can really see all the different ways and areas that AMRs can be used and really are being used today. Fulfillment and replenishment work is quite common, as I had already noted, but really if you're looking at more flexible AMR solutions that are out there, are really capable of other types of movement around warehousing and also manufacturing. And I think sometimes that manufacturing component gets left out when we talk about autonomous mobile robots. And the other great thing about this technology is that the workflows themselves, they can actually be adjusted intraday. And so if you have an AMR solution or an AMR doing one type of task, say in the morning, they can also be set up to do an entirely different type of task midday or later in the day or on a different shift. Next slide. So this gives you a little bit of a compartmentalized view around some of the things that AMRs can do. Over on the right-hand side, you see really more the general warehouse movements, order fulfillment, replenishment. Those are the things that really fit there. On the manufacturing side, I'd really like to break this down into three different sections: pre-line or station, in-line, and then end-of-the-line movements. And so before reaching any sort of manufacturing line or station, you've got kitting and consolidation movements. Intra-line or at the stations, you have replenishment of non-inventoried items, things like screws and labels, and that at the end of the line for manufacturing, you've got movement basically into finished goods inventory or into an RMA or QA area, or straight to pack out or shipping. And then the third category there around inventory management, I'd really like to talk about it more in terms of asset management, because it not only applies to inventory, but also the tracking of assets. As an example, if you're using reusable packaging. But essentially what we've been able to do on the RFID side, if you do have RFID technology deployed, is that AMRs can be enabled to do tracking tasks like inventory location checks or inventory count check cycle counting autonomously. Anyone with any sort of broader and long-term focus around flexible automation should be considering this platform-based approach to deploying AMR technology. Slide. So case study. So this is a case where AMRs were performing a fulfillment workflow in a very mixed inventory environment. Essentially, the AMRs were used to move picked product from a consolidation area to an ASRS induction area. And it was absolutely a mission-critical workflow for the distributor. And you can see the significant productivity improvements that they were able to report back to us, ROI in less than 1 year. Next example. Here we have essentially it was a GPS technology provider. And in this case, the AMRs were used in a manufacturing environment to deliver kitted parts to manufacturing lines. The big benefit here was the redeployment of staff onto the lines themselves and reduction, in some cases, the elimination of any sort of overtime pay. But it really does speak to some of the things that Matt already touched on around the shortage of labor, the ability to redeploy labor into higher value tasks, and the ability to automate some of those tasks that they're currently performing that are quite repetitive.
Yeah, so this is an example of an integrated workflow solution similar to the one you just talked about there, Joe. This is a manufacturing environment where it is an assembly line that we're manufacturing components off of. In the current operations, essentially, those manufactured goods are pooled at the end of that line, and then there's additional work that happens within that facility. And so those individuals have to take that and drop it off at other production lines, whether it's the green line, the blue line, or the purple line. And these things may be located in a wide variety or wide space inside of the facility. So it takes, one, the knowledge to know where those items are to be routed, and two, it takes time to get those items there. So there's inefficiencies, twofold inefficiencies. And so this particular example here, we've leveraged our routing software and integrated with the shelf-based AMR to be able to route the finished goods appropriately to the next stage in the manufacturing, improving the quality for that delivery, as well as allowing the people to be able to stay in that work cell and continue to manufacture those finished goods, and improving the overall productivity. So this is another example of integrated workflow operation. So in this example, we have a person's doing voice picking. So that voice picking, that person's generally picking to carts. And so the voice solution is directing which items to pick and what location to go pick from. And so they're staged in a particular area and they're going to doing that operation. Once those orders have been picked, they have to take those orders and go deliver them to some other location within the facility, taking away that productivity time to transport the products over to a different location in the warehouse. And so by combining that voice picking operation with the AMR technology, we can keep those individuals in the work area more frequently and keep them there longer, so that they can be doing the value-added service while the AMR could be doing that delivery system independently. And then that voice solution can be used to direct where that may be to be shipped out to, or to be directed to in the facility, or for that matter, also direct other AMRs to that workstation to be picked to. So another couple of interesting ways to leverage the AMR technology and increase that worker productivity. So another polling question. So if you were to consider using AMR technology, where would you use it? In the order fulfillment operation, so actually doing the fulfillment, kitting and assembly, some of the examples we talked about, data collection, some of the items that Joe mentioned, or was there something else, some other ideas, some other places that you'd like to leverage material handling AMR technology? So while that polling question is being added, I'm going to talk about something different. So this is a mobile manipulator. So this is a robotic truck unloader. So this is a robotic system that we developed to autonomously unload tractor trailers or containers of fluid-loaded products. It's to address a lot of the same labor challenges that we talked about before with the AMRs, where we want to get the individuals out of a dirty and dangerous and dull environment, and we want to put them in charge of robots to go and still improve the productivity of the overall operations, but to leverage that resource, that valuable resource of that operator. So like I said, this is the inside of a trailer. If you think about it, in the middle of Phoenix, Arizona, in the middle of the summer, it is an extremely hot environment. It's very dangerous to be in there for an extended period of time. Lots of breaks, and so we want to be able to get those people out of those trailers, put these types of equipment in, and have the people that we're removing from the trailer run these machines, so that we increase the overall job satisfaction, we increase the overall retention of those individuals, and we reduce the amount of injuries that they have. So mobility. So mobility is really an enabler to this solution. Really, if you think about an articulated arm, it's not going to be able to get the entire truck. So you have to have some way of getting all the way into a 53-foot truck. And so by putting a manipulation system on top of a vehicle allows you to be able to extend that application well beyond what you could do with an articulated arm, a fixed articulated arm. Like I said, obviously it allows you to unload the entire trailer. In addition to that, so above and beyond just getting it there, it does extend the reach envelope of the robotic arm that is doing the operation. So as the machine is actually doing its operation, and I'll go ahead and show you a video of this. As the machine is actually doing the operation, we can move in and out of the trailer to, there we go. Maybe I can get this to play. So I'll continue on here. So it allows us to be able to go in and out of the trailer and reach further in, so that articulated arm can reach deeper inside of that truck to be able to pick products further up and further away from it than if we just remain static. So it really is an enabler to what we are, what we're able to do otherwise. So let's go ahead and pull the polling question up and see what we'll see what those responses are before we get into this one. So looks like 61% of the participants are looking for order fulfillment technology, 12% kitting, 2% data collection, and a pretty decent size 24% are looking for AMRs and some other material handling tasks, probably truck unloading, I'm guessing. Okay. So let's get into some considerations that we have for deploying robots. And so this goes for the mobile manipulator as well as just AMRs in general, but also overlaps to just articulated arms. So we have to recognize that much of the data for these applications really doesn't exist. So in the case of an AMR, so there's a mapping process that needs to take place to allow the robot to understand its environment and set up what the different areas are within the facility. In the case of the truck unloaders, the amount of distribution of the weights and shapes and sizes aren't really, generally speaking, known to any great level of specificity. And so when deploying these applications, there is additional information that is needed to be able to enable the robotic solution. So a lot of times we see the pilot programs can be very critical to the understanding of this variability in the product mixes as well as inside of the facility to really understand that that technology can provide that ROI to you that you would expect it to provide. As it relates to those pilot programs, typically they'll limit the scope and try to structure them as much as possible and constrain the variables so you know you're getting the value of the pilot, of the actual technology without getting too many different variables in at play. And then fourth point here is really understand what you can and can't do with robotic solutions. It's really easy to overestimate the capability of some robotic solutions. Certainly AMR technology is relatively speaking mature. Over the past, I'd say at least 5 years, the technology has matured quite nicely. But there are other robotic technologies that continue to mature. So it's one thing to be able to show a nice YouTube video. It's another thing to actually deploy something in the field that is sustainable and provides that ROI. So again, understand what those solutions can and can't do and what you need them to be able to do. So selecting a robotic integrator. So it's going to make sure that the integrator that is putting one of these robotic solutions in really should have an understanding of the automation industry. Deep understanding of robotics across their organization. It needs to have some ability to be able to understand some of the challenges that end users face and make sure that the technology that is being applied is the right technology to solve the problem that you're looking for. Project execution is key to being able to deploy a robotic solution, and for that matter, any automated solution. You need to have a very good plan, need to be able to execute that. Having a good pre-order service and make sure that it's the deployment of an automated solution is well thought out and well proposed so that when you go to execute, that's what you're doing, is you're executing, is you're not pivoting along the way. Attention to detail is a very critical piece here. Installation and commissioning, two different skills. So one thing to be able to put an automated solution in is another thing to make sure that to make it work. So there's some skill sets that are required there. And then also project management. Any automated projects that you deploy, you want to make sure you've got a strong project management organization. Reputation is another good one. What kind of references, what kind of installations have organizations provided and executed? RIA certification is another one. RIA is a great resource for organizations to be able to evaluate the robotic integrators. It's a non-trivial activity to become an RIA certified integrator. It's a it's a high bar to be set, but when you are classified as a robotic integrator, you can have some assurances that a lot of the industry practices are being adhered to. Size matters. So small organizations may not necessarily have the depth and breadth of a larger organization and how many different projects. So dependent upon the magnitude at which you want to scale, the size of that organization and the availability of resources and capacity is an important piece. And then last but not least, remember you're buying a solution, not just a robot. So to provide that value to you, to get that ROI, it is a solution that you're purchasing. It may have a robot, hopefully it will, but it is a solution at the end of the day. So on that note, we are going to open this up for some questions.
All right, thanks a lot, Matt and Joe. Much appreciated for all of that very interesting information. And as Matt mentioned, we're going to move on now to the Q&A portion of our live event. And as a reminder, you can ask an online question at any time using that Q&A feature along the bottom of your screen, and we'll address your question during this Q&A period. So we do have some questions that have come in. Matt, I'm going to go ahead and go through some of those, Matt and Joe. So let's see. All right, so warehouse examples for robotics seem to focus on add-ons to existing facilities, but what are the best applications to consider using, or when your needs are for a greenfield warehouse facility design?
Yeah.
So go ahead, Joe, you want to go ahead and take?
Yeah, I wasn't sure if you were going to jump in there, Matt, but I think actually this may be more appropriate for you to actually talk about the greenfield examples first, and maybe I could add on to that.
Yeah, so I definitely want to chime in here. So any type of automated solution, you want to look at the best of breed technologies and what is right for the end user. So there's a host of different ways to solve problems. And so that expertise to go look at what is the breadth of different types of technologies that are available and what are the challenges that end user is trying to solve here. It's all about the details here, understanding what kind of order volumes, what kind of throughput they're looking for, what are their growth and expansion plans, doing an extensive evaluation and really understanding what the end game is here for that customer, and then coming and identifying what's the right solution for them. And that right solution may be mobile robotics, it may be articulated arm robotics, it may be traditional conveyance and sortation. It's understanding what that right solution is for the customer and then providing that.
Yeah, I would say that on the autonomous mobile robot side, it ends up really being that one additional tool where, it provides that flexible automation. And I think that's one of the things that has been missing when you think about traditional warehouse or manufacturing automation, is that it has really kind of been thought of as inflexible, and it's been thought of as maybe really taking a long time to deploy. So I think what the AMRs bring to the table, and this is that additional piece that a strong consultative arm or an integrator can provide, is how does this fit in to add speed to any sort of automation deployment, the ability to roll these things out almost immediately and have them work with either no integration or very light integration into an existing or a new system. But it also has that, it provides that capability to introduce a fair amount of flexibility into the environment as well, where because of whatever's happening with the business, the needs may change, or additional automation may be brought in at some point mid-project. If there's any sort of risk associated with a scope change to the project, if it's greenfield, the other thing that it really brings is this ability to scale, not only scale the automation up, as Matt had mentioned before, but the ability to scale that automation down, where if you want to be able to move that automation, you can move it into a building that's either on the same campus, or you could even move it to that automation to a different region where you have a building in need of some automation. And so those are really the things to consider around this, and it isn't a single answer and a point solution necessarily that we're delivering, but it does give the conceptor or the designer those options and those levers to be able to provide and introduce additional flexibility, cost savings, that sort of thing into the environment.
Okay, thanks. Okay, Matt, I think that this is maybe just a misunderstanding of the way that some of the phrasing was in a couple of your opening slides. So this attendee is asking, when you were discussing the robotics evolution, you seemed to claim that the level of technology required for robotics to perform effectively in warehouse applications really wasn't quite here yet, but when will it be?
So that's a good question. It's a spectrum that we look at here. Is what we're seeing is there are clearly applications that exist today that are in the warehousing and distribution space for robotics that can be very successful, leveraging computer vision, machine learning, AI, mobility, all of these types of things. Can we do everything and anything into a warehouse that an individual can do? There's no way we can do that right now. So again, this is a spectrum, and we are moving up that chain of ability for robotic solutions to deliver more and more complex operations. But there is clearly opportunities within the space that technology is mature and ripe and capable of today, and mobility being on the front edge of that.
Okay, thank you. From your experiences, what applications for robotics in the warehouse are showing the most favorable return on investment?
It varies from customer to customer to customer. I think it really depends upon that way that some customers measure that return on investment. So some are all about just the productivity and productivity gains. Some really weigh much more heavily the impact to the workers and the physical injuries and how dangerous some of the jobs are. And so it does vary. So I don't think that there's one specific, hey, this is the right answer here, because it really varies from site to site and customer to customer, depending upon what that ROI is. With that said, there's a lot of picking opportunities. There are like what we've been talking about today, AMRs and transportation and mobility solutions like the ones we've referred to today, some good opportunities there to have a strong ROI. And of course, then truck loading and unloading.
Okay, thank you. I have a couple of specific questions about the robotic unloader that I think you could address pretty easily. The robotic unloader still requires a human to operate, or is it automatic truck unloading?
So as much as we want the robots to do everything, no, we need an operator to run the machine. So an operator oversees multiple different machines, 2-3 machines. They're responsible for doing things like opening the door, triaging the trailer, removing any kind of pallets, as well as just addressing any kind of exception modes that occur during the operation. So we still need operators. The majority of the unloading inside of the trailer is fully autonomous, so the individuals aren't inside the trailer and they're not directing the machine of how to operate. The machine's making all real-time decisions. It's using the computer vision and sensors to navigate itself inside of the trailers, as well as make the decisions on what to unload and how to unload it. But those operators then are maintaining, like I said, closing the trailer doors out, calling for the next trailers. In some instances, moving the unloader from door to door to door, so we can shift that machine side to side, and that's all done through the operations.
Okay. And then what are the carton or product to be handled limitations for using the truck unloader?
So the machine was designed for general merchandise unloading. So meaning the end customer is more of a retail parcel handling type of customer. So it's not set to any shape or size in particular. So sorry, back up. It's not, you don't have to have a specific shape and size for it to function. It identifies how the trailer is loaded and how it's stacked, and anywhere from a nice, neat column stacked load all the way up to just a pile of boxes that it's capable of unloading.
Okay, thank you. Joe, I've got a couple for you here.
Okay.
So let's see, how effectively do AMRs adapt to busy or constantly changing routes?
Yeah. So to kind of just add to what Matt had talked about previously, the thing that separates AMRs from AGVs is the ability for AMRs to essentially replan their path if there are obstacles. And with some of the better AMRs, even the ability to really avoid moving obstacles or fast-moving obstacles like forklifts or any other sort of cart that might be in a warehouse or manufacturing environment. And so with that, really what you're doing with an AMR is you're just defining a destination point, and that AMR by itself is going to be able to plan the best route there. If that route is blocked, it'll replan and take another route by itself. There's really no need to touch the system. And if there's an obstacle that it can go around, it'll simply go around those obstacles. So it's this natural navigation and this ability to replan by itself without any sort of facility markers, magnets, tracks, anything else that is associated with infrastructure modification or additions. It's that feature that really defines the difference between AMRs and maybe the more traditional AGVs that you're used to.
And so you'd say that the navigation isn't based on site mapping?
Yeah, so the navigation is based off of the AMR's ability to understand where it is within the environment, and that's established at the very beginning of any deployment, and it can happen relatively quickly. So if you're looking at even millions of square feet worth of warehouse or manufacturing space, usually a map of that facility can be created inside of a day.
Okay. Okay, so if we're looking at, integrating AMR technology into an existing facility, maybe could you speak to how to direct or connect that with an existing WMS or WCS?
Yeah, and so depending on the type of AMR system or AMR vendor or technology that you're deploying, AMRs can live outside of any sort of integration, but as you turn that dial up from an integration perspective, you can get into light levels of integration. A common one would be integration with handheld scanners, where the handheld scanners are essentially triggering the movement or the tasks for the robot, all the way into increasing levels of integration into the various systems that you already might have running, any sort of WCS or WMS. And so the software itself has APIs, SDKs, those sort of things that allow for connection into the various controls and functions of the robot. And so that's really a long way of saying that there's already a tool set available for integrating that robot movement or those tasks into an existing system where you can then have that system govern the movement of the robots.
Okay, thank you. I think you can probably both provide an answer to this next question, which is for a first-time robotic integration in my warehouse, what level of on-site robotic expertise would I need to have to support them?
Yeah, so I think that in the case of AMRs, there's really not a whole lot to it. I think one of the surprising things for us in practice when going through a deployment is, you know, there are folks that already begin the deployment process ahead of, say, any one of our employees showing up, and so it definitely helps to have someone to run point, because in some cases, some questions obviously may pop up, and so we would like someone that can hopefully take ownership of that deployment. But when there isn't any sort of integration involved, there really doesn't have to be a robot expert. The whole idea behind having this sort of automation is so that you don't have to have that expert, and so that's part of the key to if you're looking at where this technology or AMR technology is on that cycle of all the universe of robotic technologies that can go into a warehouse or in manufacturing. It's one of those things that's relatively light as far as any sort of on-site robotics expert.
Matt, do you want to add?
Yeah. So generally speaking, from an automation perspective, the solutions that we provide are maintainable by technician level individuals. So, you know, we're not looking to have somebody that has a PhD in robotics to be able to support these. So when we design solutions, both an AMR and, for that matter, even articulated arm or the truck unloaders, we design them in such a manner that they can be maintained and supported from a technician's perspective. In addition to that, then, our organization also offers 24/7, 365 online support or hotline support. So we provide that so that if there are any challenges with any kind of support for the automated solution, no matter how simple or complex, we have staff to be able to support that and help to be there at any hour of the day to help you resolve whatever issues that you encounter. And that also includes individuals that are located throughout the world, but to be able to help address those challenges.
All right. I think we have time for a few more questions here. You know, maybe not so much focusing on the challenges, but is there, you know, if you could say if there's a number one pitfall to be aware of when implementing robots in the workspace? Again, I guess that could probably be answered by both.
Yeah, so I would say in the case of AMRs, you know, the things that you need to do to ensure success, you know, the first thing is a really good site survey. It's really understanding what the environment looks like prior to any deployment, and really making sure you address any of those gotchas before you know, people start shipping things around. And then the second piece there would be making sure that the workflows themselves are well defined initially. If you do those two things right, it really does make for successful and very speedy deployments.
Yeah, I'll second that as well. Is this understanding the environment and understanding the variability. It's one of the challenges that we face with any automated solution inside of a warehouse when we talk about AMRs or articulated arm robots or truck unloaders for that matter, is understanding that environment and and make sure that it is an acceptable area for operations. And I think when you have a good understanding of what that product mix that you're running, talk very specifically about a truck unloader. We don't unload pallets. That's not what the truck unloader does. It unloads fluid-loaded trailers. And so, doing a site survey, evaluating the trailers, understanding what what the volume mix is an important key piece here, and it's a simple thing to do and evaluate. But doing that up front is it's a vital piece.
Okay, Joe, this one's for you. In your experience, how has integration of AMRs coupled with human traffic and forklift traffic presented challenges from a safety standpoint, if it has?
Yeah.
Or has it?
Yeah. So I think it's interesting with AMR technology, there are a number of providers out there, but I think that for us specifically, we actually see customers using our AMRs as even a buffer between, say, forklift traffic and a busy or congested people area, if you will. And that in part is really kind of speaks to the number of things that we've done around designing for safety, just that good LiDAR vision, the 3D cameras that we incorporate to really detect objects that reside above or below any sort of LiDAR vision, and then that combination of filters and IP that properly handle moving objects based off of speed and direction of travel. All those things get built into how an AMR deals in that sort of congested environment, or an environment where there are things that are moving around that are quite fast. And so I would say that we're quite comfortable, and we've been in practical applications where our technology has actually been used as a buffer as well to increase the safety of the particular environment.
Okay, thank you. Let's see here. Matt, why don't you maybe take this one first? What are some of the preliminary conditions of an existing facility that should be considered, such as, level floors or power availability or anything else that you can add that you think would be an important consideration?
Sure, yeah. So again, it depends on the type of automated equipment that we're talking about here. So like if you talk about truck unloaders, there's an evaluation of like the dock levelers and the angle of the docks, and there's a lot of just details that need to be evaluated. Power requirements are another good one. So like with the AMRs is where do you locate your chargers and making sure that that infrastructure is in place. Typically, it's pretty straightforward with regards to power and air. I mean, those are kind of like the key components to any kind of automated solution. You need power, and sometimes you need air, and speccing out what those are. Maybe Joe can speak to a little bit more about the floors and some of the other requirements as it relates to the AMRs.
Yeah, so for AMRs, just to address the floor question, the floors have to be relatively flat. That is part of just how the robots assess where they are in the world, and it ensures the proper positioning of the robots as well. They can't go over really large cracks. I would say that, because the robots have that vision of a warehouse, fairly large warehouses can be quite repetitive in terms of just rows and rows of aisles. They all pretty much look the same from a robot perspective, but the more permanent fixtures there are in an environment, the better. Again, it'll depend on your AMR provider or who you're dealing with in terms of how they address some of these things that are maybe more general issues within the industry. But I think that there aren't a whole lot of requirements outside of the fixtures themselves. I would say Wi-Fi, at least in our case, is a requirement. But again, there aren't a whole lot. The floors are pretty much the big thing, and then really probably Wi-Fi would be the next biggest.
All right, thank you, and I think that's probably all the time we're going to have for questions today. I want to thank all of our attendees for their participation, and we do have quite a few questions we were unable to answer during the duration of today's live event. We will be sure to follow up with an email response on those questions. And as a reminder, within approximately 48 hours after this live event, you will be able to access this presentation on demand at intelligrated.com/on-the-move. You'll also receive an email in a couple of days with a link to the recorded event. So on behalf of Honeywell Intelligrated, thank you for attending today's On the Move webinar. A special thanks to Joe Lau for joining us for the presentation today. And we'll be sharing more information soon about our next webinar. And as always, we hope you will be able to join us then. Thanks and have a great day.